Okay, this thing's messing with me, sorry. I had just did this. Well, anyway, now hopefully it's all kind of fixed up for you guys. I think I have audio, so if I'm going for a while, my mouth's moving and not hearing anything, please. Hopefully someone will say something. But it looks like my mic's working. All right, so welcome. We're in week 4, which at the end of this week puts us about a quarter of the way through the semester, which is good. We're getting through that, and we're almost to the end of the sort of boot camping and refreshing stage of the semester. So I'm trying to. Happy Monday, Edcast. Nice to see you. Hello, Magenta. Hello, Isnam. The video, I don't know if there's anything I can do about that, although I can. Let me see if I can make an adjustment back here. Well, it's a little bit better. Not the best. The video is probably just a networking issue, so I wish I could do something about that. So welcome to everybody, and hello to you if you're watching the video later. Anyway, week 4, the end of this week, roughly a quarter of the way through the semester, and we'll be getting very close to the meaty stuff for the semester, not just the review kinds of stuff. This is the fall semester, so most people are coming off of at least a summer where they probably didn't do much coding. And I personally find that it's easier to, like, I have to get warmed up again if I take off for a while. I just kind of lose my rhythm. I lose my muscle memory a little bit. So anyway, that's why these 4 to 5 weeks of review are here. I had, by the way, so I assumed that I was going to see certain kinds of struggles on the week 3 labs, and had all these notes about the things that I felt pretty certain I would see just based on past experience. But just about everybody got all or most of the lab exactly right. There are a whole bunch of different styles, and that's fine. There are a whole bunch of different ways to come at solutions to problems. I'll look at an example of that just to show you from last week's lab. But you guys did very good work on that, so props to all of you for that. The main things that are just, well, the source code formatting is not a request. That is you need to get in the habit of styling your source code well. You should not ever see me do any poor source code formatting. So all of my samples, all of my starter files, they all use what I hope is a consistent and widely used style. You can Google source code formatting, and in fact, you will find that Google itself has style guides for how to write C++ and how to write Python in a whole bunch of languages. And Airbnb, I think, has a very good style guide. A lot of companies have their own style guides. So in effect, we are all working together in our sort of one semester company, and I'm going to try to steer everybody to good style. You don't have to use my style, but I am going to point it out when you're not using consistent style. For most of you, that's not a problem. But if it needs work, I'll point it out. Doing things like curly braces always is a good idea. Tabbing things over, that kind of stuff. And then sort of it's really not, it's not even a recommendation. It's just a challenge to all of you is to see if you can be a bit more succinct in your logic. And I'll show you some examples of that. So sometimes instead of writing an if-else statement, you can actually craft a statement that captures the entire idea of your logic in one place and in one statement, and it will make sense to you and other programmers, and reducing clutter on the screen can be a great benefit. So I'll show some examples of that. But yeah, you guys made me scrub out all of my week 3 tips and notes, my last week's, because everyone just kind of worked it out. So that was good. Of course, I can't see how much time that took and who got together in study groups or got help from a tutor, but whatever you did, that worked. So keep up the good work. New stuff this week. So we're talking about structs. my style of programming is to use structs when structs make sense, and to use classes when classes make sense. I don't like overly complicated code myself. So when a struct makes sense for my purposes, even in C++, which is kind of wants you to use classes, I use structs instead. So if you've had the Go language, you know what a struct is, and you're going to see very familiar things this week just with the C++ syntax. So I think that you should know about structs. I think you should have those in your toolkit so that you can make wise choices about when to use a struct, which is sort of technically by its intention meant to be simpler than a class. Then we'll also look at ostring stream, which is one of my favorite kind of C++ styling tricks, is the ostring stream. So I'll show you how to use it. It looks like a big, long, complicated thing, but it turns out that if you can do a cout to produce outputs, then you already know how to use ostring streams. You just didn't know it. I'll remind you about the magic formula and show you how you can use those with ostring streams. And then finally, we'll look over quickly the spec and the requirements for project 1. That comes up sooner than later. Okay, so let's walk through the content this week before we look at anything that looks like code. Okay, so as expected, the lab will use structs. It will use ostring streams to format data. And we will continue using unit tests, which for you guys will be pretty much the rest of the semester. Yeah, some people in chat are saying the video is going blurry on you guys, and I wish there were anything I could do about that. So far, we haven't looked at anything that's a huge deal, but there must be a network issue or something. Unfortunately, all of that is completely out of my control. But maybe it'll stop. I hope it will stop. Actually, there is one thing. Give me a moment. I'll be right back. I did think of one thing I might. All right, we'll see. I can make one change in my network, and we'll see if it makes a difference or not. I hope that it does. Okay, so structs, ostring stream, and more unit tests. But you guys will be doing unit tests for the rest of the semester. So hopefully you find the unit test to be a comfort because they tell you if you did or you didn't. Okay, Magenta says it is better. So that one change apparently does make a difference, and I'll make note of that. I was trying to do a multitasking thing, but I'd forgotten about it. Okay. Okay, yeah, that's all the network changes I can make. Okay, so goals for the week. The readings as always, so all of the things that we're doing. Readings for. Of course, you're not limited to doing the readings. I just kind of tried to do some of the work up front for you and hunt down readings that were relevant to what we're doing in class this week. And then the lab is, you'll get used to this. You did good on it last week, so it'll be the same idea. You'll have code to implement. You'll have a unit test that uses doc test that will be used to evaluate the correctness of the code. And then I leave myself not much room to get on you about source code formatting other than just to tell you in your comments that your source code needs to be formatted if that's an issue for you. And then this is kind of I know it's kind of a silly thing, but I want you to be thinking and talking about Project 1. So the kinds of things that you can talk about in terms of Project 1 are how might you go about designing the data structures that you need, or are you going to use data structures at all? Will you use arrays? Will you use structs? Will you use classes? Those kinds of things you can kind of discuss and toss around ideas about how you're going to design the system that you'll implement for the first project. Talk about what do we know, what don't we know, where can we find that information. So anyway, that's just, and also kind of mostly to get your eyes turned toward the first project. Those are big. They're worth 500 points a pop. So you don't want to let those hang, and you want to get started on them and finish them strong. All right, and then the reminders, let's look and see, when is project 1 due? October 2nd. So that seems like it's a long time away, but if you wait until October 2nd, I suspect you're going to find that this is a bigger project than you thought that it was. So please have a look. I have some screenshots of my own implementation, just so if you don't have any idea about how you might want to format your output, at least you have a sense of the flow of my program, the way I've formatted my output, the information that I'm storing, that kind of stuff. All right, let me go back, get the lab queued up, and then we'll talk about structs and O-string streams. Oh, and some examples of being slightly more succinct. So let me make sure you can still see what I see. You can. Okay, so I'm going to make a REPL for week 4. I don't know why I did that. What? Wrong place. So these will be the part of the notes that I upload, will be these samples, which I intend to give you everything that you need for the lab, but not directly into the lab, since what would be the interest for you if I did that? Okay, so first we'll talk about the just the week 3 stuff. So we had a function. It was something like this. And I'm literally right now, and I hope that the video is unblurry enough that you can see these brief examples. Maybe I'll comment them out. So the documentation on this function in the week 3 lab said, if name is empty, then just return a greeting that says hello. But if the name is non-empty, then return a greeting with the name in it. So there's several ways that you could do this. The way I would have done it would be something like this. I don't remember the exact spec, but that part doesn't matter. So mine would have looked like this. Yeah, I probably don't even need that. How would I? Yeah, let's just do it this way. Although I'm less comfortable with that. That's fine. Okay, so this is the way roughly I would have done it. So strings have an empty function in them. I'll show you where to find this stuff if you haven't already found it. I think one person, maybe 2 of you, did it this exact way. So the things to note here. So string has a function called empty that will actually return true if the string is empty and false if it's not. I'm going to open up a tab here and do C++ standard string. It's helpful if you can tie your Google search to the specific thing in the libraries you're looking for. So standard string, probably standard : isn't necessary, but at the same time, it probably helps. So the first link, C++ reference, I'm just going to go to it. And then I'm going to scroll down. Let me just make sure you still see what I see. You do. Scroll down. So there's a whole bunch of stuff. How to construct them, how to assign stuff to them. Begin in. We're not doing iterating. Okay, so size and length. return the length of the string, so we can use those to solve this problem, which I'll show you in a second. But there's also this empty. Test if string is empty. If you click the link, returns whether the string is empty, a bool. So true, it's empty, false, it's not. So you want to start looking around at these library documentations and see if there's things already in there that make your life easy. The reason why this empty one is a good choice is because it matches the language of the problem. So the function says, if the string is empty, do this thing. Otherwise, do something else. Well, this function actually just already has the word in it, which means that it makes the algorithm about as clear as it could possibly be. If that string name is empty, do this. That's not the only correct solution, but I like it because when you read the code tells you what it's doing. Oh, if the name is empty, then I'm just going to say hello. Otherwise, meaning the name is not empty, I'm going to say hello with their name. So that's one way you could have done it. Or if you realized that the size of an empty string should be 0, then you could have done this test and that would work just as well. Notice that when I say the size, the algorithm is not as clear anymore. If the size is 0, so it's clear to a programmer type who should realize that the size of an empty string is 0, but it's not as, it doesn't read as pretty as it's empty. You could also, by the way, have done if name.length equals 0, which would have gotten you the same result. You also could have done and just tested literally the value to be an empty string. That one would work as well. So all of those work. My personal preference is the one that kind of matches the language of the algorithm, if you will, where we're testing to see if it's empty or not. So that would have been my choice, but those others were correct. And there's nothing wrong with any of them, and mine's not better. I'm just sort of explaining to you why I would have made that choice. Okay, so there's the greet function. See, there was another one that was bool is factor, and then we had 2 ints. I'm shortening this up to make so that you have less to look at on the screen. Numerator, denominator. So a lot of people ended up doing something like this. So if the numerator mod the denominator equals 0, return true, else return false. So if there is no remainder when you divide the numerator by the denominator, return true. But you can actually squish this whole thing down without losing any of the meaning of the algorithm, without losing any of the readability of the algorithm, by getting rid of all this extra junk and just say, what I really mean to do is just return the result of that test. Is the numerator evenly divisible by the denominator? And that's more succinct, and I would argue it still is readable as far as the algorithm goes. So no information is lost to anybody this way, and it's a little bit less places to make mistakes or to misread some code. So it's not a requirement, and it doesn't make an if-else better or worse than this solution. I'm just sort of showing it to you so that you can consider as you improve with your confidence and your skills with C++ that you consider some of the options for making your code while keeping it readable, making it slightly more succinct, so that people and yourself coming back to it later can clearly understand the algorithm and have less stuff to make mistakes around. And then the last thing, no one had this problem, but it's something to be careful of. I forget what the algorithm is. So I'll use doubles. I think we used doubles. So no one made this mistake, but it's something to be careful of. I forget what the algorithm is, but this is another place where really you can just, what is Fahrenheit to Celsius? I have to look it up. What's the algorithm? Okay, 5/9 times Fahrenheit minus 32. 5/9 times Fahrenheit minus 32. So something to be on the lookout for. This kind of thing can easily go south. So notice, by the way, I didn't even use an extra variable in here because I really just need the algorithm expressed. It's okay if you declared a variable and did the math and returned the variable, but you don't necessarily need to do that. And it's still, people can see what the algorithm is. They understand that the result of that will be returned from the function. And it's a little bit more succinct. But the thing to watch out for here is that 5 divided by 9 is 0. So you want to be very careful about that. In fact, I will just let me just hopefully make the problem happen so you can see it. So be wary about using integer values around floats and doubles because sometimes things happen that you wouldn't expect to happen. So Fahrenheit, so 32 Fahrenheit is equal to now that one should be 0. Oh, except for I'm using strings. What? Oh. I'm sure you guys have had this where you just have a bad typing day. No, that one didn't work. Okay, good. So something ain't right here in this algorithm. I'm just kind of raising this. It didn't seem to affect anybody, but be on the lookout for this kind of thing. So the algorithm kind of says, do this part and then multiply it by this part. Which that looks correct. Let's try 212. I know I don't want to waste a whole bunch of time on this, but should be 100 in Celsius. Okay, is also 0. So anyway, be on the lookout because this is an easy mistake to make. Your testing should turn this up, which is a place, for example, where unit tests are handy. That should be 100. So what happened? Well, 5 divided by 9 is 0. The integer 5, which is what this is as far as C++ knows, divided by the integer 9 is 0. And if you take 0 and you multiply that by anything minus 32, you're going to get 0. So how do you head this off? For me, if I know I need to be doing floating point math, I am actually explicit about it. I make everything be floating point if the whole problem is meant to be floating point anyway. So that's how I handle the problem, is because C++ does 5.0 divided by 9.0 way differently than it does 5 divided by 9. So be on the lookout for that kind of thing. That can be a problem where you think that you're doing floats, but you actually accidentally introduce some integers and you get a 0 somewhere in there and it breaks the entire algorithm. So no one seemed to have that problem, but that can easily happen. And maybe some of you did and you figured out how to fix it. But be on the lookout for that kind of thing. Mixing integers and floating point. Make sure that you understand what you're doing with your math. Okay, so that was everything. The last thing I'd point out to you is the formatting, which most people already have down. But if you don't, when you're in a block like this greet function, everything in it starts tabbed over one. Everything. When you get into a subblock, well, everything in it starts tabbed over. Same for this second subblock. Everything in it is tabbed over one. That's just proper source code formatting style. It makes it easier to read. It makes it easier to understand what belongs with the if and what doesn't. It makes it easier to see kind of what the extent of the function is and what belongs in it and what doesn't. Like this bool is factor is lined up with string greet. So they apparently are siblings and not somebody being the child of another somebody in the code. So those kind of details are important. Like you can lose a job over this kind of thing if someone's putting you through a code review and you're giving them sloppy code to look through. You're not going to get a good review for that. So develop good habits. And most of you already have them, but if you don't, then work on that. Okay. I can get rid of, well, I'll just comment these out for now. And I'll keep going inside of here. Okay. So that's just some style issues and some thinking about the math you're doing when you're mixing integers and floats. And also thinking about where you might be able to kind of make a more succinct algorithm that still is easy to read and understand, but with less chances because of extra code of making a mistake with it. Okay, so now let's move on to struct. Let me just make sure that you can still see what I see. Okay, so struct is a way to structure data. You all should have encountered this concept in one way or another coming into this class. If you took the Go language and you've seen things that Go calls struct, and they are the same thing effectively. If you've taken C++ and you didn't see a struct, then hopefully you saw a class. And a class is very similar to a struct. They also have classes in Python, classes in Java, classes in JavaScript. Most of the languages, in fact, I can't imagine that any of you had your first semester using a language that didn't have struct and or class features in it that you would have used. So hopefully that's true. Okay, so the purpose of a struct, to me anyway, is when you have multiple variables that you're declaring that are all related to a single entity inside of a program. So for example, let's just do a car as an example. So if we wanted to model a car in our code, and by model a car, I simply mean what aspects, characteristics of a car are relevant to a computer program. Once I've identified the characteristics of a car that are relevant to this computer program I'm making, then I translate those characteristics into data types and variables in the computer program, which is called modeling the thing. So I'm going to model a car. And in this case, it'll have a make. Funnily enough, it will have a model. It will have a year, which can be an unsigned int, because it's never going to be a negative year. Probably would have a paint color. We'll give it a miles per gallon rating. The fuel capacity. that kind of thing. So when you begin the process of modeling a real world entity like a car, you find those characteristics that are relevant to what you're doing inside of your computer program. Notice, for example, that there's characteristics about cars that I left out. Like, does it have 4 doors? Does it have what size engine does it have? What kind of fuel does it use? Those things are not relevant to the computer program I'm making, so I'm not modeling those characteristics. I'm modeling only these characteristics that you see on the screen in front of you. So this is how we might start. And then hopefully you remember this from Programming Algorithms 1. Well, what if I had 2 cars or 5 cars or 10 cars? Well, at the beginning of Programming Algorithms 1, you might have said, well, I guess I'm going to have to say make 1, model 1, year 1, color 1, mile per gallon 1, fuel capacity 1, and then I can copy and paste all those. And then for the second car, I'll just bump up the number so that the second car has its own set of variables, and the third car, and that's where I'll stop. Notice, by the way, these are all tabbed in one, and there are blank lines to separate the sections, which is also just styling stuff. Make 3, model 3, year 3, color 3, miles per gallon 3, fuel capacity 3. And you can start to see how the more cars that I need to represent in my code, this way that I've modeled the data does not scale up very well. Because if I have 10 cars, I'm going to have 50, 1, 2, 3, 4, 5, 60 variables if I want to have just 10 cars in here, which is a terrible way to model this data because it doesn't scale up very well. So one of the techniques that we use when we have a whole bunch of kind of related to one entity data, like a car in this case, and we notice that it's not scaling up very well, because every time I want to add a car, I have to add a whole bunch of new variables. This is a good place for a struct. I tend to capitalize the names of structs and classes. It's not a rule in C++ that you use a capital letter for your struct names, but it can help when you're reading code. If you're in the habit of capitalizing structs and classes and you see a word in your code that's capitalized, then you might think, oh, that's one of my classes or my structs that I created. That's all I'm doing that for, is because it makes my code slightly easier for me to read if I know that that's my habit. All right, so what do I put inside this struct car? I put the variables that were used as the model. Tabbing over one because I'm in a block, by the way. And then I don't need the numbers anymore. I just have this struct. So the thing to remember about this struct is that this is not a variable. This is a custom data type, kind of. I think of them as composite data types. So car is a brand new custom data type that I just defined that is composed of these variables. Or a car is a composite data type. But most people would just say car is a struct. And we all know that what that implies is that car probably has data fields inside of it. But it's not a car or even a representation in my software of a car. It's simply the definition of the thing. All right, so how do I turn these variables into a car? Well, now that I have the struct, I can say car1. And car1, because it is a car, has in it all of these fields. And then I can do the same for car2. And car3, and as far as I want to go. And that scales much better, right? So every time I need a new bundling of those variables to represent the car in my software, I simply use the type car and create a variable of that type, which is, by its definition, composed of multiple data fields. So how do you use one of these things that's composed of multiple data fields? You use the variable, which I would get in the habit of thinking of this as an instance of a car. So car1 is an instance of a car, which is the object-oriented language for it. So car1 is a car, which means that car1 has a make and a model and a year and a color and an MPG and a fuel capacity. If I want to access the individual data members of car1, I use car1 followed by a dot, followed by the desired data member, which in this case would be the make of the car. Equals, I'll call it a Ford. Car2, if I want to access its make data field. And hopefully you can see without going into it too much, the way C++ can tell the difference between car1's make and car2's make is that it has car1 as this label on its bundle of the data, and car2 has its label, car2, on its copy of the bundle of the data. So every time I declare an instance of a car, I get a whole new set of all of these variables attached to that specific instance. I will make this one be a Chevrolet. Make this one be a Nissan, doesn't really matter. So then I can begin to use the data fields of the individual car instances. So I still have the data. Now this is going to start to seem like it's not scaling up all over again, but it is slightly easier to reason through if you're reading the code that, oh, car 1's make is Ford, and car 2's make is a Chevrolet, and car 3, well, its make is Nissan. And they don't cross over each other because each of them has its own separated copies of these data members, these fields, that you access by the name of the instance itself. Okay, so there's that. Okay, so now we'll start using functions to deal with the next scaling problem. So now we have the scaling problem that if I were to set up I'll call it Model T. I assume that when you bought it, you just said, I want a T? Or would you say a Model T? I don't know. It's kind of weird, isn't it? What model? The T. I don't know. Year. We'll say, I don't know. They probably were making them in 1925 still. PG. I'm sure it was miserable. Probably like 2.5 miles per gallon or I don't know what. Fuel capacity, who knows? Let's say 10 gallons. Okay, so there's car 1 all with all of its fields initialized, and then I could, if I wanted to, well, let's do this in stages. So hopefully everyone sees, though, that I now have a new scaling problem. And by that, I mean, if I'm going to set up car 2 that way, I'm going to have to do all of this same work for car 2, and then all of that same work for car 3. And I'm right back to the situation where I'm just having my code kind of explode on me. So this is a place to put a function. A function will help me eliminate some of this problem of the code not scaling about. I can use a function to capture all of this behavior in a more succinct way so that can be reused for all the cars. So heads up. In fact, I am doing something wrong on purpose. I'll ask you about it in a moment. the idea doesn't change, but I'm purposely doing something that's very small but very wrong. But this is the basic idea. I realize at this point, I can't be doing 6 lines of code for every car because now I'm losing all of that succinctness. That compact code that I was gaining by the struct, I'm now losing when I initialize all the data fields. So is there a way I can eliminate this problem where I have to repeat it over and over and over and over and over again? And the answer is yes. I can make a function to capture that behavior and get rid of and make the code scale a little bit better in the second step. So I'm going to say void initialize car, and then actually let's do it that way. We'll return a car, and then we will initialize it to a string make string model int year double mpg. I'm going to drop down to the next line, which is a thing you should do too instead of letting it run way off the screen. Double fuel capacity. This guy jumped way out there when I didn't want it to. It should be lined up with the opening of the function. Okay, and then tabbing over once because I'm in the function. So what do I do with these things? Well, this function is going to return a car. So I'm going to make a car, and then I'm going to initialize this car to all of these data fields. So this car's make will be the make that came in as a parameter, and its model will be the model that came in as a parameter, and its year will be the year that came in as a parameter. Its MPG will be the MPG I got from the parameter, and finally its fuel capacity will be the fuel capacity that came in as a parameter. So how does C++ figure out which make is which make and which model is which model? And like, how does C++ know this one and not the one in the struct? So it's not really a question that's easy to answer by chat, so I'll just answer it. The way C++ can tell those apart is that I'm attaching this particular make to an instance of the car struct. So C++ knows that that make is the one that's inside of this instance of the struct. C++, in the case of this make, well, it's the only other make anywhere in this scope. So C++ is going to want to look somewhere in the scope of this function, unless it's told to look somewhere outside the scope on purpose. C++ is going to look within this function, and the only other make here is this one that's a parameter. Same for model. The only one that C++ can find in this scope is this one. So that's how C++ tells them apart. This one is the one that goes with the struct. It can tell because of the C dot in front of it. Okay, so now I had this initialized car, and now I can take all this stuff and I'm kind of doing it purposely slightly slow if you're following along so you can keep up. All right, and now I am back to where I can scale my code a lot better again. This is a Chevrolet. We're in software. Might as well get ourselves like a sweet 1980 Corvette, which probably got barely better gas mileage, by the way, but it probably had a little bit more fuel capacity. I don't know. So you see how the function in this case, Nissan. I'm not big into cars actually, so I don't really know. Probably they still make Sentras. They probably get like crazy good gas mileage. I don't know. That's probably overestimating it. But they don't carry much fuel. Anyway, kind of made up. So anyway, you see how where it was kind of starting to explode again, I used a function to compress it back down to make it more scalable again. So now I have this function, this function that, why did it unfold everything? I don't know. I have this function that does all the work of setting up the data fields for a car, and I just take that and I overwrite car 1 with this guy's data. And same for car 2 and same for car 3. And now I've compressed the code back down. It's much easier to read. It's much easier to maintain if I discover that there's something wrong with the way I'm initializing a car. Well, all I have to do is come back to the initialize car function and take care of that problem. There's nothing wrong with that function. I decided not to do the wrong thing. Sorry. I decided to put that idea off for a second until we got the basic idea worked out. Okay, so hopefully everyone's following though that structs and then this function that I've written to kind of work with a struct, those are all there because they help me manage my algorithms better, but they also help the code scale up better. So I can get more and more and more cars without just a giant explosion of lines of code to initialize their data fields and stuff. Okay, so now let's do another example of that. So here's another example of where functions can be handy. So let's say I want to print out the information about car 1. So I will do cout car 1 is a car 1 dot model Ford, probably a space here, make first car 1 dot model, and then it's starting to run off the end, so I'm going to be careful here and drop down to the next line. Built in car 1 dot year end line. Okay, so and then I could fairly easily repeat that for the other cars. By the way, if you find yourself doing this, it should be a red flag. So I'm copying and pasting and touching code. And now I am doing something wrong on purpose. Just to give you a sense of why a function is helpful. So car 3, car 3, car 3. So now I'm accessing the data fields to print out information about the cars. Before I run the code, can anyone see the mistake before they see it running? Like by a line number, if you see it. If you don't see it, that's fine. But I've made a mistake somewhere in these print lines. Line 55, good one, Isnam. Line 55 has a problem. I forgot to change car 1 to car 2 there. So when you find yourself copying and pasting code, which you will do a lot of, the moment that you copy and paste code should be a warning that, is this the best way to do this? Sometimes copying and pasting is the best way to do it. Sometimes it's not the best way to do it. You sort of just have to learn by experience. But the other thing if you find yourself copying and pasting and then also editing the pasted line in a whole bunch of different places, good one, Edcast. Also got line 55. If you find yourself copying and pasting and you find yourself editing the pasted code in several places, that also is a red flag that this is a place where I could easily make a mistake. So I'll fix that and just make sure that it works. I don't know what I did that's wrong. I have a sense of what I did wrong. That should have worked, actually. No, it's crashing. Well, that's definitely a warning. Although it shouldn't have. Yeah, it shouldn't, unless I did something in these functions that's broken. No, because I already ran those functions. So I have a crash. Car 2, 2, 3, 4, 5, 1, 2, 3, 4, 5. My guess is it's in the initializers. So the most complicated code is that stuff. So let's comment it out and see if it runs. Oh yeah, I don't have a car 1 and a car 3 anymore. So maybe I did introduce the problem that I thought I was going to avoid. Although it shouldn't have. I saw it. I made a mistake in this function. It's a hard one to find. But I just figured that the couts were not the likely culprits. So now I see the problem. This function is supposed to set up and return a car, but nowhere in it did I ever return a car, and the program didn't tell me that. It just crashed. So that was going to be a pain for me to find. But I saw it as I was starting to comment things out, and I thought, what's wrong with the initializer? I peeked up above and noticed that, oh, crud. It's supposed to return the car that initialized, and it never did. So this thing can't work. Okay, so there they are. Ford Model T built-in, Chevrolet Corvette, Nissan Sentra built. All right, so everybody looks okay. Well, that's good for you to see me do that. There was one that I didn't have a return statement, and it crashed for it. Yes. So Magenta, you're anticipating my next step. Pardon me. So Magenta in chat has pointed out, couldn't I just make a function to represent this printing behavior? And wouldn't that kind of give me better control over the outputs and less likely to make mistakes? And the answer is yes. And that's exactly what we should do, is we should make a function to represent that behavior. So as a build up to that, Magenta, this should be in a function. I'm just going to show an example of, so that you're copying and pasting and that you are editing lines multiple times should be a warning to you that you should make a function for this, because there's a good chance that every new copy with its edits and every new copy with its edits, you're going to make a mistake somewhere. So if you put it in a function and you make a mistake, then it's the one function that has to be fixed and not all of them. And then I'll show you just one more example where, so now I think, well, I should have put like miles per gallon with it. So I'm going to add the information about miles per gallon. I'm going to drop this down to the next line so it looks better. Okay, so I've decided, you know what, I probably should have printed the miles per gallon. So I'm going to do that here. It needs a space in front of it, But now I also have this problem where now I have to repeat that. So now I'm copying and pasting and editing some more. At this stage, I should have the thought, and this is echoing what Magenta said in chat. I should have the thought that this is a place, I ought to be using a function for this. If I put a function for this, I can apply the function to every instance of the car exactly the same way. If I want to make a change to the way it's printing out, then I can easily just do that. And then it would apply to all of the cars in exactly the same way. So let's do that. Let's make a function for this. Print car. So Magenta is going to look a little bit in Go when we get down to the... it might not. It might look almost exactly the same. I'll hold that thought. So I'm going to have a car. So I'm just going to pass a car in. I'm just going to call it C, and I'm going to do printing on the parameterized car. So let's take all this stuff, put it in the function, and then let's carefully clean it up. So it won't be car1. In fact, I'm just going to get rid of the whole car number part and just go make model built in. And then I think I'll separate out the pieces in line. So it's not going to be car1 anymore. It's the parameter. This one, C, model, year, MPG, end line. And now all I have to do is pass each car in and it will be printed. So I will do print car, car1, print car, car2, print car, car3. And because of the function now, I get the exact same behavior on every instance of a car. And if I want something different, I go change the function, and then it applies to every one of the individual cars. So that's better. I'm much happier with the function version of that. Yeah. Okay. So that's the basics. You will see in the lab this week that there are other functions. So what I'm going to do a slight switching of the gears to is talking about not just sort of using functions to scale up, but using the features of C++ to make this code more efficient when it executes. So this function print car as an example. C++ is a pass-by value. Language, and what that means is Go is similar, and you'll see you'll be reminded of the technique for C++. Passing a car to this function right now is passed by value, and what that means is that a copy of the car has to be generated, and then a copy of the car is being used to print out the information. Now that's fine in terms of the information that you see. A copy of car1 is going to print the same information as if it were car1 itself. Same for a copy of car2 and a copy of car3. The only downside is really that this is forcing C++ to generate an entire copy is not the most efficient way to do this. And a copy of a struct like this one just kind of is noticeably inefficient. A copy means that it's a copy of 1, 2 strings, a copy of 3 strings, a copy of an unsigned int, and a copy of 2 doubles, just to print this information out. It's a lot of copies of stuff, and car1, car2, and car3 all have to have copies generated by this pass-by value parameter. So what do we do to get rid of the copy being generated? Well, we pass it by reference. And if you pass by reference, then you won't get a copy. You will actually have a reference to the original, and your algorithm is slightly more efficient now. And this is really most relevant, this pass by reference thing, when we're talking about structs and classes. Making a copy of an unsigned integer is about the same as passing a reference anyway, so that kind of thing doesn't matter. But when we're talking about structs, you're going to see me using pass by reference a lot. And the reason I'm doing that is because in this case, I don't need or want a copy to be created of that complex data type. So this will prevent the copy being made. Now we still have a problem is in that if I were a meanie, I can take the pass by reference and I can actually alter the original vehicle. We can prove that. By printing it out after the printing. So this pass by reference has the unfortunate side effect that someone can get in here and touch this function. They can actually alter data that I didn't intend for them to be altered. So it's a Boydmobile now, and notice that after printing is done, it remains a Boydmobile, and that's because of the pass by reference. If I were to do a pass by value, then the bad function writer can't change it permanently to be a Ford, even though the print statement makes it look like it's a Ford. So we like the efficiency of the pass by reference. We don't like the possibility that some bad programmer can go in there and use the reference to alter our data for somewhere else in the program. So that's a problem. So how do we get rid of that? We can add const to this to prevent edits to the pass by reference item. So watch what happens now, I hope. So I need to make, so the bad programmer is saying, haha, I'll make every car be a Boydmobile. And what are they going to do about that? So we're trying to protect against that now by putting this const in there. And I get an error. So what does the error say? The error is basically saying the thing is constant, so you can't touch it. Now, there's a whole bunch of them being repeated, const. So the constant eliminates the possibility that an accidental overwrite can happen or that someone being a bad actor can overwrite something. So this combination of const with pass by reference gives us the efficiency of not making a copy of a complex data type and the safety of not accidentally altering data when we don't mean to, such as in a print function, which should now work because I'm not trying to change it anymore. So you're going to see this in the lab, and you need to think of the two pieces. Oh, the pass by reference is there so that a copy isn't generated. The const is there because they don't want to change the original data. They just want to read it or view it. Okay, so now let's go fix initialize car. So what's the problem with initialize car? It's hard to see. We'll look at examples of this later, but we can see that initialize car is making another car. So every time I initialize a car, I'm actually creating that other car in the function and then just kind of writing its data over car one. So every one of these initialize car function calls is actually creating a whole new car in the function itself, which is also not the most efficient thing you could do. Why do I have to make a car to initialize a car? And the answer is I don't have to make a car to initialize a car. What I'm going to do instead, let's see, I think I'm going to comment this. I'm going to copy this, and then I'm going to alter it and then comment out the original. So let me comment this one out. So let's talk about the same kind of thing. Can I make a function that doesn't have to create a whole extra car just to initialize the data fields in a car? And the answer is yes, I can. And the way I would do that is I would pass the car by reference to the function. I'm going to drop this piece down to the next line and clean it up some. So I can pass a car in by reference. I don't need now to return a car. I don't have to make a car. I can just use the reference to alter the data fields. So I just said we don't want functions. Get rid of that comment. We just said we don't want functions. We like the efficiency of the pass by reference, but we don't want functions that can accidentally overwrite data. That's true. The difference for initialize car is that when we call this function, we know that its purpose is to overwrite data. So as long as we're aware that that's what it's supposed to do, then it feels okay to give the function a reference to the car. If a function is taking a reference to a car and is not supposed to overwrite any data, then we want it to be const. If the function is supposed to overwrite data, then we don't want it to be const. We want to give it access by reference so that it can actually do that job. We try to keep these kinds of functions to a minimum because we don't want to just be constantly overwriting data all over the place. But in this case, I consider it an okay trade to not have to generate the extra car every time a car needs to be set up. I don't want to make a car and then make another car and then copy the other car to this car. And then that's just a whole bunch of extra stuff being created when the program runs that doesn't need to be there. So now to initialize a car, I'm going to send the car in. It will be sent in by reference, and then its fields will be overwritten. So what does that look like? So we create car1, and then we pass it in to be initialized. I'm going to take this line out. We don't need it anymore. So now car1 becomes a pass by reference parameter, which means that this function can take this parameter and overwrite its data. I'm going to do the same for these other two. So this is part of the challenge of the lab this week, is for you to think about what is going on in these functions. I'll go through them actually before I quit today. I hope I have time to remind you. So be on the lookout for pass by reference and ask yourself, is it being passed by reference with a const so that it's kind of a read-only efficient pass? Or is it being passed by reference without const, meaning that the function should be set up, should be overwriting some or all of its data? Okay, so there's a struct. There's some functions that work with instances of a struct. And one more stop, and then we'll look at the lab, and then I'll quit. So the last thing. Oh, wait, sorry, Magenta asked a question. So I still have a copy of the car function stored in car1, car2. No, there's no car function, Magenta. So I'm not sure if I understand the question, but I'll go through it and hopefully answer as I go. So the cars themselves only store these data fields: make, model, year, color, miles per gallon, and fuel capacity. The functions are actually separate from the car themselves. The only way that the functions actually kind of work with cars is that cars are sent in as parameters. So this is a little bit different from Go, because you will have been used to doing car1 dot stuff. And we don't do it that way with structs in C++. Or at least I'm not doing it that way with structs in C++. So there's no copy of this function. This function is just sitting there waiting, and when a car is sent in with some data, it will take that car and assign values to that car's data fields. So there's no copy of this function that goes with each individual car. There's just this one function that can be used by having the different cars passed into it. Yes. So Magenta asks, but the data will stick to each car. Yes. So car 1 is an example. When it's passed in by reference, the function just refers to it as C, but it's car 1 when we pass it as. So in this case, car 1 is labeled by the function as the reference C, even though we know by the way that we passed it, it's car 1. Okay, yeah, maybe I'm getting at the answer then, Magenta. So in the case of initialized car 2, car 2 is going to be labeled by the function as the reference C, but we know by the way we passed it that it's car 2's data fields that are being updated. And then on this last one, the function will label the reference as C, but we know that it's actually car 3 that it's working on, and car 3 will get all the data fields updated. So I don't know. I don't know if I answered that question. I hope that I did. But yes, with the pass by reference method, when we do c.make and we have passed in car 1, it's car1.make. And C++ doesn't show you the connections very well. You have to make them for yourself. So to figure out which car is c.make, I have to look at the calls to the function. And then I realize, oh, in this case, it's going to be car1.make is Ford, car1.model is Model T, car1.year. In this case, the C in the function is actually car2 dot, and then the last one, car3 for all of those. Okay. Yes. So Edcast asks, so the car that I'm initializing is being passed in, and the answer is yes. So I create the car, and then I pass the car to the function by reference, and the function will initialize all the data fields for me. And the reason why I'm doing that is because I can guarantee with the function that the data fields are all being consistently initialized. And the code also scales up better because this, with one version of the function to reference, is a lot easier to look at than copying and copying and copying over and over and over again. Okay. So one more thing. This is actually probably the more difficult idea, part of it at least. But I think it's a good thing to know how to do. And I also just try to get you in the habit over the course of this semester. So I would, and a lot of people would also say this, a function that has cout statements in it, a lot of us would call that a side effect of a function. And the idea is that the cout part, the user interface part of our program that does outputs to the screen, we don't like having that sort of just sprinkled all over our code all over the place. Inevitably, as you get bigger and bigger software systems, if you have functions that have couts in them, you're going to forget about some, and your program's going to be spitting out output sometimes, and you forget where that output's coming from. So generally, we don't like to create functions that have side effects like this. And by side effects, I mean things that appear in the program's output that you may or may not have expected. So in the case of print car, that is an expected effect of the function, is that output's going to happen. But in my opinion, it's a far better approach to try to contain all of your outputs in one part of your program. For example, in main, and try to get rid of functions that do couts independently of main. So that's what this next part is about. How do we make a function like print car that doesn't do a cout on us? So that's what this other topic is about. I would like you to at least have been exposed to the idea that we don't like to just sprinkle couts wherever and call it good. We want to take all of our outputs for a program and try to contain them in one place as much as possible, and eliminate the side effects of functions out there who are just kind of doing outputs whenever they want to. Let's see if we can get all the outputs kind of contained into one place in our code. So how would we do that in this program? How would we make it so that this function does not have this side effect? Well, this function, by its nature, has this side effect. So we'd need a different function. So that's this next part is, how can I get a similar behavior without having the side effect of the cout statement? So here's how we would do that. So when we have a function whose job it is to produce output, but we don't actually want to make the function do the work of the output itself, we can make the function instead create a string with the output that it desires. So we'll do that. I'm going to call it car to string. So instead of doing the output in the function, I'm going to make the function put all the information together in one string and then return that string and let the part of the program that's supposed to be doing the outputs handle the outputs for itself. This is common in programming, but less common in C++ because it's kind of not really built in as an expectation much of the time. Okay, so to create a string that could be presented as output about a car, we're going to need a car. I'm going to make it a const. I don't need to overwrite any data here. I just need to be able to read the data. So I'm going to pass by reference to avoid the copy, but then use const to avoid an accidental overwrite. And then I'm going to introduce something new into our code. So I'm going to scroll up and I'm going to add an include. It is stream, which is short for string stream. That sounds fancy and out there a little bit. It's not nearly as awesome as it sounds, but it is awesome. Yeah, so Magenta asked because I'm doing the couts outside of main. Anywhere that I might call that function, those couts are going to happen, even possibly in a program where I didn't want the cout. So this will, I think you'll understand it better as we just continue with the practice that I'm introducing to you. Try to contain all of your cout type statements in one place in your program, and don't let them sprinkle themselves around all your functions. When you need an output from a function, like you want to take the car's information and present it for printing, make a function that returns a string instead, and then the outputting part of your program can actually cout the string about the car for itself. So it's going to seem weird at first, but you'll see it in the lab, and you'll just kind of follow the practice, and then hopefully the reasoning behind it will begin to dawn on you. You'll have projects later in the semester where you're going to want to put couts in places that you shouldn't. So you'll have plenty of chances to practice this. Okay, so how do we get the couts out of there? We're going to use string streams instead. Let's see if I can. So Magenta asks, like a member function that brings in the car info that is used to initialize it. So I think if I understand the question correctly, Magenta, so is this function we're creating kind of similar to a function that would access all the info? And it is. This is going to be a function that will access all the information about the car without overwriting it. And instead of just doing a cout for itself, it's going to build a string containing all that information, which is something in memory, and then let some other part of the program decide what to do with that string, either to print it out on the screen or to print it to a file or to send it over the network or whatever it is. The advantage of this technique is that if that information about cars is needed, it doesn't have to go to cout now. It can go wherever someone wants to send it. It might be cout, but it might be to a file or somewhere else. So we need this include, and we need this using. Which is not nearly, it's awesome, but it's not nearly as scary in code as you might think it's going to look. So what does this oString stream thing look like in code? So car to string. So we declare one. I'll just call it the output. So this is what it is, and it seems very scary and fancy, but it's not. That's the name of the variable. So output is an oString stream. oString stream is just a fancy string. It's a fancy string that has a neat capability about it that we would like to have access to. So this output is the key. At the end of the function, I'm going to return the output as a string. So this output to start is this fancy kind of string stream. The output at the end is simply going to be a plain old string. And you'll get used to this as well, but it's not nearly as big a deal as you might be thinking that it is. So what do we do with this thing? Because it's a string stream, we can actually use output just as if it were cout. So we can literally take the cout that we wanted and instead of sending the output directly to the screen, we will send it into memory. So we use all the same setup on oString stream. We use the alligators, we can put spaces, we can use the end line on it. We can do all the stuff to this oString stream as we can to cout so that it feels just like doing a cout, but it doesn't go to the screen, it goes into memory. And the advantage of that is that allows us to collect all the outputs that we want as strings and then print them from one place. That's the whole function. I'm going to take the car. I'm going to do the output into memory, not to the screen. So I do the output the same, but instead of cout, I go to memory. And then this .str basically takes this weird kind of string and turns it into a regular kind of string, which is what the function wants. It's actually fairly trivial. It's just there's a lot of new concepts going on there, including why do we do these kinds of functions at all. So I get all that. For now, it's just a matter of getting it to work and then, take the time to ponder it a little bit. So we would like to not have couts sprinkled all throughout our code, but there are times when we need the information and we need it formatted in a way that we could present it nicely. So in those cases, we will create a function that will build and return a string like an output, but it won't actually show up on the output yet. All right, so how do we use car to string? We do this. So now we can contain all of our couts inside a main. There would be no couts sprinkled in our functions anywhere else. If the program is producing an output, it is coming from main. It's going to look the same because car to string actually produces the same format, but it puts it in memory and allows the program to print it to the screen later. So now we've contained all of our output statements inside a main. We still have the formatting ability of the function, but we're not doing a side effect. This does not show up on the screen from some function somewhere. It shows up on the screen because we're doing all of our outputs to the screen in main. And this doesn't seem like that useful at this stage of the game, other than for completing the lab, but it is quite useful when you get more complex systems and you end up with like weird outputs coming from places and thinking, why is that happening then? And how do I get rid of that? I had misspelled it somewhere. Capital T. So the output looks the same, but the difference is I don't have some function out there in space doing outputs to the screen. I have the function doing the formatting into memory, and then main is taking the formatting from memory and placing it on the screen, which is just, in my opinion, good design. And you'll thank yourself when you don't have to go chasing down random outputs from your code. But the other advantage is I could easily take these and put them all in a file as I'm printing them to the screen without having to make a new function. I can just do that. I'm not sure. Oh, that won't work as written because I don't have the include for it. I'm not leaving it there. I just wanted to point out to you that it's not always the screen that we want things to go to. Sometimes it's a file. Sometimes it's the network. But it gives us the power to contain all of the outputs in one place. Let me make sure it still runs because I touched it and then undid something. Okay. So there's that. I think there's a formatting. How am I doing on time? I'm starting to run really short on time. Let's do the formatting thing real quick. So you may have seen, let's see. It's how do we want to, well, you may have seen something like this where you have fixed set precision to show point. So you may have seen an output that uses these, and you probably even saw it written like this. This sort of what we call the magic formula for showing floats. For doing an output, which allows you to control floating points. So I want 2 places past the decimal. And I want to always show the decimal, even if it's not necessary because it's a .0 kind of value. Anyway, these formatting things can be used on these same outputs. So anything that you see with a C out next to it can also be done to this output. Just the C out goes to the screen, the output goes into memory where it can then be moved around and displayed or printed at your leisure. I think this comes up in the lab, but we'll look here in just a moment. So anything that you can do to C out, you can do to these O string streams. And that's very powerful. It's just that it doesn't, O string stream doesn't go to the screen, it goes into memory. And because it goes into memory, it gives you the power to call it and then do with that bit of memory whatever you want. Okay, let me get the lab pulled up. And I think I'm just going to look at the raw code today. So this is a unit tested one like last week. So the instructions are all there, but same deal. Okay. So let's just go quickly through the lab and see what is familiar. Yeah, I probably should leave that in my notes. I'm going to upload this code as notes. So I'll put it in here. So these are just some hints for you looking up later that I will leave in these notes that I will post. I think I can bring that up here. Yeah. So this is to help you with a little bit of searching. You will find I went and did some Googling before class just to make sure this is going to be true. So you'll need to look up how do I do floating point outputs in C++. If you do a Google search, you will find the magic formula, I think. Yep, first link. Marina's blog, the C++ magic formula. Which is right here. And the thing to remember is, in fact, I'll just do it. Why don't I just do it? Proper formatting. I'm not doing it to see out. I'm doing it to the memory where I'm formatting things. And then I think I need to include IO manip. So those of you watching the stream or the video, iOS, I did mean standard iOS. You'll notice that now they're all formatted to 2 decimal places. That's because of the magic formula that I use. So I decided to go soft and put it in here for you. So if, this will be posted as code samples from the day. And of course, it's also here in this video. But notice I applied it to the string stream and not to the cout because I wanted to format what it looks like in memory and then print it later. Kind of a cool thing. So I wimped out and I gave it to you. So there it is, and it'll be uploaded as a code sample. All right, so last thing I got to get done. So let's look through the lab real quick. I'll notice at the top, so that output string stream is coming in. There's the iOS that I know I was using for the magic formula. There's the OString stream itself. All right, so the struct is called item. It's got 3 members in it. Here's a function called init item being passed a reference called I that will be used to assign the parameter data to the struct fields. The second one, total value, has a const item reference, which means that we don't need to alter the data. We just need to read some of its information so that we can compute something and return a computed value. So that's why it's const. Here's one that is not const, which means that the function must be designed to alter data. It's got some logic in it as well. Here's another one, not const, but by reference. So it's going to be used to alter one of the data fields. Here's to string. I guess you can't do that. Weird. Const by reference. So all I need to be able to do is read the fields. And then I noticed something that's somewhat familiar from the sample today about that. And then the unit tests, which are relatively short and straightforward. All right, so I didn't do an example like reduce quantity and increase quantity, but I did do what I hope were the most difficult things with an example of the car. So I'm going to stop there. Thanks for being here. Thanks for the questions. If you're watching the video later, I hope you're having a good week. What else? The first project, please make sure that you read through the specification and the specific requirements where the points come from, and start planning out project 1. At least I recommend that you do. In case you don't know how long it might take you. It's a while away yet, but not that far away. So you want to get into project 1 sooner than later. Yeah, I think that's it. So I will see you on next Monday. I hope you have a great week. Piazza, Canvas Inbox, office hours, as always, available for assistance from me and or your classmates. So Have a great week, and I'll see you on Monday next week.